Hello guys, welcome back to my channel Code Cruxes. Today we will solve another problem based on binary search, and our problem is finding the floor and ceiling of a given number. It is a very easy problem, but we are doing it because we will solve it with two methods. First is the iterative method and second is the recursive one. Since recursion is also a difficult topic and it is as important as well, so it needs to be solved, right? So we will practice this problem with both the ways. Okay, so let's go to the question. It states that we need to find the floor and the ceil of the element x, which is given into nums array. Okay, so let me explain the question to you on whiteboard. Suppose our integer array is 1, 4, 6, 8, 9 and we need to solve it. Suppose x equal to 2. That means we need to find the floor of 2 and the ceil of 2, right? Okay, so how I remember is the floor is below us, so the floor of the element 2 will be an element which is smaller than it or equal to it. So in the array nums, 1 is smaller, the immediate next smaller element to floor or to 2, and hence it is the floor of it. Similarly, ceil lies above us, so the ceil of 2 will be immediate next bigger element to 2, and it will be 4 in this case. Okay, so now we will have to solve it with binary search. And so we will have a low, a high, and a mid that will be initialized by 0 and minus 1 and like low plus high by 2. And now it is simple, like first case of it will be simple, like mid if our array mid equal to x, that means we have an element that is exactly equal to x, then we have to do nothing. Then both the floor as well as the ceil will be x only and will return, right? This is the case first. But what if our element is if a mid is greater than or equal to x? Like if it is greater, let's check here. Suppose that this is our mid, right? This is our mid in our case, and if it is greater than 2, as it is, so what we will do, we have to find this means this can be a potential ceil of 2, but we need to find an element which can be even smaller than 6 but larger than 2, right? So we need to move to the which side, to the left hand side, and hence what we will do, first of all we will assign ceil as a mid. Maybe it is the highest, maybe it's the immediate next highest element for 2, but if it is not, then we to find the move to 4, right? And hence what we will have to do, we will have to assign high to mid minus 1. I hope you got this point. Like we have to move to the left hand side if we find that a mid is greater than or equal to x. Similarly for the case 3, or you can also do it greater than, because equal to x has already been handled. It does not make any difference. And the next case will be just the opposite. If a mid is smaller than or equal to x, then what will happen? We will have to find the floor. The floor will become a mid, like it can be a potential solution, and in this case low will become mid plus 1, because now we need to search in this area. Like suppose 6, we have found 6 which is not smaller, so it will be the case of here, by which we will move to the immediate previous smaller element. So I hope this is clear. This is what we discussed till now, and now let us see in the code. So suppose this is our element, we have declared the n as size of the array, then low, high, and we need to return it in pair. So we have taken a pair called answer and initialized it with -1, because if any element is not present, we have to return -1 here, right? So this is just the same code I have written. If nums mid equal to x, then just simply return it, or else these are two other conditions. So I think that it is easily understandable. These are the two conditions. Here we move to the which side? We move to the left side, because we need to find an element which is the immediate bigger element, right? And similarly here we move to the right side. That's it. That makes the code, and at last we'll return the answer, which will contain both the floor and the seal for it. So let's try to compile it. Yeah, it got compiled, and hence let's try to submit it as well. Yep, it got submitted, and we have implemented our binary search solution in the iterative form for this question. So thank you for watching, guys, and I think this is clear to you. If anything is doubtful, you can ask me in the comments or rewatch it, and in the next video we will solve the same question with the help of recursion. We'll start slowly with easy questions so that we can make understand the concepts and like make bigger codes also for both binary search as well as this recursion. Okay, thank you. Bye bye.